Hello everybody, welcome to Fraction Review. Now today is our fraction test, and on the review is just some of those concepts that we either learned earlier before school was closed or just some things that I felt like we were struggling with a little bit. So I'm going to run through some of those lessons. Okay, complete the number bond. Now in this top portion here, I have 3/3, right? Which is equivalent to 1 whole. And down here, I have 2/3. So I'm thinking, how many more thirds do I need to get 1 whole? If this is my shape, and I already have 2/3, right? Down here. How many more thirds do I need to complete 1 whole? And if I look at this, there's just one extra section. I just need 1 more third to get 1 whole. Okay, moving on. Okay, now this is a bit tricky because we have 2 different shapes here, but it's asking what fraction is shaded. Now the first thing I have to think about, what is the piece size? And I always have to look at just 1 whole. Just look at this one. If I look at this one, what are these? Are they eighths? Are they halves? Are they thirds? If you look at this, 1, 2, 3, 4, they are fourths. So my bottom number is going to be 4 because that's the size of the piece. But I have more than 1 whole here, right? I have 2 wholes. I'm not going to just say I have 2 wholes. I have a certain amount of pieces. 1, 2, 3, 4, 5, right? I have 5 fourths. I think sometimes we get confused and we just count all of the pieces all together. And if I count all of them, I can see there are 8 of them, but they're not eighths, right? I'm looking at just what 1 whole has. Okay. Now this one. Each part of the number line here is a whole. Here's a whole, here's a whole, and here's a whole. It's the same as a circle or a tape diagram. It's just on a number line now. It looks a little different, but it's the same. How many 6 are in 3 holes? Okay, so if each one of these holes looked like this, you would say that there's 6 6 in 1 hole, right? Now I'm just counting the spaces here. 1, 2, 3, 4, 5, 6. Okay, it's the same. I have 6 spaces, 6 equal parts, same as down here. 6 equal parts. 6, 6 give me 1 whole. So how many are going to give me 3 holes? Well, a little trick to do this is I can just count by 6, right? I know that 1 times 6 is 6, 2 times 6 is 12, and 3 times 6, 6, 12, 18 is 18, okay? So how many 6 are in 3 holes? I just do 6 times 3. Okay, so in my answer, I would say I have 18 sixths. Okay, next one. Now these were a bit tricky, but I'm just trying to make this shape that's not shaded look the same as the one that is shaded, okay? What fraction is equivalent to 2/4? What fraction is equal? Well, I can see over here I have fourths, and I have 2 of them shaded. On the other side, I don't have fourths, right? I have 2 halves. But I want to figure out how much of this I need to shade for it to look like it's about the same amount shaded. So I know if I kind of shade this part here, from here to here, and from here to here, that's about the same amount of space shaded. It should be equivalent. So what part of this is equivalent? 2/4 is equal to or equivalent to what shaded part over here? Well, if I look at this, it's equivalent to 1/2. Okay. Now this is another way of doing this. I'm trying to figure out this missing number. And I know this can be kind of confusing, but it's like I'm given all of these clues and I have to figure out that missing piece, okay? So I'm given my numbers over here. I can work with those. And I also am given my 2 numbers on the bottom. That's gonna be where I start. How do I get from 2 to 8? 2 times what gives me 8? 2 times 4 gives me 8, okay? And I'm going to move that same bit up here, okay? 1 times 4 gives me 4. So 1/2 is equivalent to 4/8. Now if I was going to draw that, okay, halves over here, and then over here, I'm going to draw my 8ths. Now if I shaded in 1/2, and over here I shaded in 4/8, I can see that this looks the same as that, right? Half of the shape is shaded for both. So those fractions are equivalent. Let's try this one. How do I get from 4 to 8? It's a little different than the last one, but I can use those same numbers. 4 times what gives me 8? 4 times 2 gives me 8. And I'm going to move that up here as well. Now I'm going to do 3 times 2. 3 times 2 is 6. And if I showed that same thing over here, I'm going to show my diagram. Okay, and then over here I'm going to show 4ths. Okay, I'm going to show that I'm shading in 3/4 over here. And I'm going to shade in the same amount, 1, 2, 3, 4, 5, 6, right? I was doing 6. So that, as you can see, I shaded in the same amount on both. So those fractions are equivalent, even though the unit fraction is different for both, right? I have 8ths over here and 4ths over here. Okay. Now this is the last bit, and I want to say this one last time as I feel like some of us are still missing this piece. When the number is smaller on the bottom, the piece is greater. It is bigger, right? Because instead of splitting a pizza up into 10, I'm only splitting that pizza up into 3. So those piece sizes are going to be way, way bigger. I don't even know if I could do it. Let me see if I can show you some tenths. Okay, not bad. Okay, so as you can see, even though 3 is way smaller than the number 10, it's different with fractions. I'm comparing how big the piece is. So this 1/3 is so much bigger than this 1/10. So the smaller the number on the bottom, the bigger the piece, right? If I had halves, 1/2, 2 is even smaller than 3. And as you can see that 1/2 is bigger than 1/3. It takes up even more space. So the smaller the number, the bigger the piece. 1/3 is greater than 1/10. Okay, everybody, I hope this review helped a little bit. If you have some more questions while you're taking the test, please feel free to message me. Okay, everybody, have a great Friday. Bye.